as I was saying, whenever I take a derivative, the derivative of a constant is 0. So taking derivatives, well, it tells me many things about slope and concavity and maximums and minimums and all sorts of wonderful things. I lose a little bit of information. I lose the information as to like what constant was added to that function. I can't tell. So when I am finding an antiderivative, unless I have more information, my antiderivative is going to have some constant c stuck to the end of it. And I got to keep this c with that function as I go through. Now, what derivatives do I know? I know polynomials, and I know, well, I don't want to touch rational functions for right now. Maybe I'll get back to those on a future lecture. I know the logarithm. Yeah, I know the exponential function. I know sine and cosine, and I can add functions, and I can multiply functions by constants. All of those things are derivative rules that I know how to do. Well, every single one of those derivative rules I can turn around backwards, and I get an antiderivative rule. So what's the antiderivative of a power of x? Derivative says decrease the exponent, multiply by the old exponent. Antiderivative says I got to do that backwards. So my antiderivative will say increase that exponent, divide by the new exponent, like this. Let me double check. I like to double check. I like to make sure things are making sense. If I did take the derivative of this function right here, I've got a power of x. I need to bring down that power. I'll get n plus 1 divided by n plus 1 all times x to the power n. Oh, yes, yes, I did get the thing that I said is its derivative. That's looking good. Oh, wait a minute, hang on. I am dividing here. So this formula, this antiderivative formula, will only make sense as long as the denominator in the formula is not 0. I'm still not allowed to divide by 0. Darn. Okay, so this antiderivative formula tells me the antiderivative of x to the power n so long as n is not equal to 1. That's the only time this formula will not work. Okay, well, let's keep going. What if I want to take the antiderivative of x to the power -1? I might want that sometimes. In fact, I want that a lot of times in my life. What function has x to the power -1 as its antiderivative? Oh, I think I know this one. It might be more obvious if I write this out differently as 1 on x. Oh yeah, that's the derivative of the natural log function. Okay, so because I know the derivative of the natural log function, that means I know the antiderivative of x to the power -1. What else do I know? I know the derivative of e to the power x is e to the power x. That means my antiderivative of e to the power x is also e to the power x plus c, right? Antiderivatives, I always need to keep track of this plus c, unless I have enough information to find out what number that is. The derivative of the sine function is cosine. So the antiderivative of cosine is minus the sine. Excuse me, the antiderivative. I'm looking at the wrong row here. The antiderivative of the cosine function is the sine function. Let's see if we can get this right for the next row here. The derivative of the negative cosine function is the sine function. So the antiderivative of the sine function is minus the cosine function. I know that I can do derivatives of two different functions added together by adding their derivatives together. So if I want to take the antiderivative of two things added together, I just need to do those antiderivatives separately. I'll have a single constant of integration. And if I have a constant multiple of a function, say alpha is some real number, the antiderivative of alpha times a function is just alpha times the antiderivative of that function, again, plus some constant. So all of these observations, all of these tools are coming from taking my derivative rules and flipping them around backwards, because now I'm going in the opposite direction. So like I was saying before, every single derivative rule has a corresponding antiderivative rule. For right now, we're going to focus on why you would want to do an antiderivative, trying to figure out the useful form for using the chain rule backwards and using the product rule backwards. That's more calculus 2 stuff. So for my next lecture, I'll be talking about why we would want to use antiderivatives and how we would use these tools to help us solve problems. And maybe I'll be lucky enough to have you again in Calc 2, and we can talk about more advanced anti-differentiation techniques.